Hi, welcome to Search and Study Tech. Today topic is Kruskal minimum cost spanning tree algorithm. Minimum cost spanning tree here. Now this is one of the popular algorithm for finding the minimum spanning tree from a connected undirected graph. This is you can use the greedy method. So what are the steps? First step 1, remove all the loop and parallel edges. What is meant by loop and parallel edges means, for example, this is a graph. This is a graph. This graph consisting of any loop. Okay, this is a loop. So for example, here it is A and here it is B and C. For example, this one is the cost is 2, here it is 3, here it is 4, for example here it is 5, here it is for example 1. So first remove all the loop and parallel edges. So here the loop is there, you can remove that one. Here the parallel edges is there, A to C, two edges is there. So you can take only, you can keep it only minimum cost edge here, it is a 2. So you can remove this edge. So that is the first step. And second step is arrange all the edges in their increasing order of the weights, because you can find out the minimum cost path. So it is a minimization problem by using greedy method. So next one is add the edges which has a least weight without forming a cycle. Now we can see, you can discuss one example. So here it is a, so can draw here the what are the number of vertices is there. V3 is the one vertex, V1 is the another vertex, and V6 and V4 here, and V2, this is the vertex 2, and this is the vertex 5, vertex 7. So these are the vertices is there. Now we can see, first step is there any parallel loop or any loop or parallel edges in this graph? There is no loop and parallel edges. Then directly you can go to the you can use the second step. What is the second step? What are the edges is there? You can arrange in ascending order. Okay, so that is, so V1 to V4 is cost is 1, and V6 to V7 is also cost is 1. Now we can see V1 to V4 the cost is 1, and V6 to V7 the cost is also 1, and the second least cost is V3 to V4, V3 to V4 here, V3 to V4 the cost is 2, cost of this edge is 2, and V1 to V2 also, V1 to V2 the cost is 2. Now we can check the next minimum cost edge here, V2 to V4, V2 to V4, here it is, the cost is 3. So next least cost is V3 to V6, sorry here also there, V3 to V1, V3 to V1, you can take 4, here the cost is 4. Next V3 to V6, V3 to V6 the cost is 5. Next least cost is V7 to V5, V7 to V5 the cost, V7 to V5 the cost is 2. Next you can consider V6, V4 to V5, V4 to V5 the cost is 7, and V6 to V4 the cost is 8, V6 to V4 the cost is 8. You can count the number of edges here, it is a 12 edges is there. So you can see here 5, 10 edges is there, few edges is missing. So if you can see 1 and 2, 3, 4 and 5, 6, 7, 8, 9, 10 edges is there. So this is the edge 1, V1 to V4, V1 to V4 is over, and V4 to V7 is also, you can take it, V3 to V4, V3 to V4 also can take, and v1 to v2, so v1 to v2 also can take, then v2 to v4, v2 to v4, here it is v2 to v4 also can consider that edge, and v3 to v1, so here it is v3 to v1, you can consider this edge, v2 to v3 to v1 and v3 to v6, v3 to v6 you can consider this edge also, and v7 to v5, v7 to v5 you can consider this edge, and v4 to v5 here you can consider this edge also, and v6 to, this is weight is 8, v6 to v4, this is v6 to v4, that cost is 8, also you can consider this edge. So here missing edge is v4 to v7, v4 to v7, you can consider that one, v4 to v7, you can consider that edge also, and also v2 to v5 is there, v2 to v5 is also there, that cost is 10. So here the 12 edges is there, all 12 edges you can ascending, you can arrange the ascending order here, then you can take the v1 to v4, v1 to v4 you can connect these two vertices, it is over, then v6 to v7, v6 to v7, it is also, the cost is, here it is 1, here it is also 1. Next you can consider the v3 to v4, v3 to v4, v3 to v4, the cost is 2. Next v1 to v2, v1 to v2 here, the cost is, v1 to v2, the cost is 2 here. Next one is v2 to v4, v2 to v4, if you can use this edge v2 to v4, then it form a cycle, that's why you can ignore this edge, you cannot add this edge. Then v4 to here it is v7, v4 to v7, you can add this edge, that cost is 4 here, v4 to v7, the cost is 4. Now v3 to v1, v3 to v1, if you can consider this one v3 to v1, it form a cycle, so that's why cannot consider that edge. Then v3 to v6, v3 to v6, if you can take this one, it form a cycle, v4 v3 v6 v7 and v4 and v3, so it can form a cycle, that's why you can ignore this one, v7 to v5, v7 to v5, okay, you can add this edge, okay, you cannot form a cycle, that's why we can take it. Then v4 to v5, v4 to v5, so if you can add this edge, it form a cycle, that's why you can ignore this one also. And here it is v4 to v2, the cos v4 to, so here it is v4 to v6, v4 to v6, v6 to v4, that is 8. If you can take this one, it form a cycle, that's why you can ignore this one, this edge also. Next last one is v2 to v5, v2 to v5, if you can consider this one, it form a cycle, that's why that is also you can ignore it. So you can see this is the minimum cost spanning tree. Is there any cycle is there in this graph? There is no cycle. And also what is the cost, minimum cost path is, so here it is 1 2 plus 1 3, 3 plus 2, that is 5, 5 plus 4 9, it is 1, 9 plus 1 is 10, and v7 to v5, that is 6, so 10 11 13 14 15 16, so the cost, minimum cost is 16. And also how many number of edges you can remove in this graph also you can consider. For example, e minus n plus 1 is the number of edges. How many number of edges is there? Already you can count 12, minus how many number of vertices? It is 3 and 4 and 5 6 7, 7 number of vertices is there, plus 1, that is equal to, so that is equal to 6 number of edges you can remove. Then this graph act as a spanning tree, you can see, you can remove this edge, you can see. So here I am not consider this one, v2 to v5, I am not consider this one, so this one, and here also v1 to v3, you cannot also consider this one, and v2 to v5, v4 to v2 cannot consider this one, and v3 to v6 also cannot consider, and also v4 to v6 also cannot consider. Then here it is v4 to v5 also cannot consider. Okay, so then, so how many number of edges is removed? 1 2 3 4 5 and 6 number of edges removed. Then this is a spanning tree. The spanning tree must be a connected graph. If any disconnected graph is there, it cannot form any spanning trees. How many number of spanning trees are possible for this graph? Spanning trees. Okay, NCR means here it is n is the number of vertices. How many number of vertices is there? 7 vertices is there. 7. See, how many number of edges you can remove? 6. That is equal to 7 factorial by 7 minus 6. That is 1 factorial into 6 factorial. Okay, so that is equal to 7 into 6 factorial by 1 factorial is 1. 1 into 6 factorial, you can cancel this 6 factorial. So here 7 spanning trees are possible for this graph. And also one more important point, how many vertices is there in this original graph? Okay, in spanning tree also that number of vertices must be there. So here it is 4 plus 3, 7 vertices is there, 3 and 4, 7 vertices is there. So this is the minimum cost of spanning tree by using Kruskal algorithm. It is a greedy method. It is a minimization problem. Thank you for watching this video. Later classes you can discuss Prim's algorithm, how to find out the minimum cost of spanning tree by using greedy method. Thank you for watching this video.